this lesson, we're going to graph polar equations. We're also going to look at tests for symmetry, and then specifically graphing circles and limacons. First, we're going to start with the test for symmetry in polar coordinates. When we test for symmetry, we check three different things. The first thing we check is symmetry with respect to the polar axis, which again, we're more familiar with referring to it as the x-axis. In order to do this test, you replace theta with negative theta. If an equivalent expression results, the graph is then symmetrical with respect to the polar axis. Here's a diagram that shows you that symmetry. You have r comma theta, which is this polar coordinate, and then when you replace theta with negative theta, it takes this point and reflects it down here because you're rotating down with your angle, still going out the same value r. And then you can see that this point has symmetry across the polar axis. The second one we're checking for would be symmetry with respect to the line theta equals pi over 2, which we also refer to as the y-axis. In order to check for the symmetry, we replace r and theta with negative r and negative theta. And if an equivalent expression results, then the graph is symmetrical with respect to theta equals pi over 2. So graphically, we have, again, the original point, r comma theta. We replace both r and theta with negative r and negative theta. So with this point, we then rotate down for the negative theta, and then r being negative would reflect this point back up here. And so then you can see going from this point to this one, the graph is symmetric with respect to the line theta equals pi over 2. And then finally, to check for symmetry with respect to the pole, or also known as the origin, replace r with negative r. And again, if an equivalent expression results, the graph is symmetric with respect to the pole. We have a note down here that says when replacing the above expressions, if the resulting equation is equivalent to the original equation, then the polar curve has that symmetry. But if not, then the polar curve may or may not have that symmetry. Okay, I'm going to do a quick review on even and odd identities. We have even functions and odd functions. For the even functions, what's going to come up is evaluating cosine of negative x. If you have this, it's equal to positive cosine of x, versus for your odd functions, if you have sine of negative x, it's equivalent to negative sine of x. So we're going to use these when we check on our test for symmetry. This example says, consider the polar equation r equals 4 sine theta. This example says, consider the polar equation r equals 4 sine theta. For part A, we're going to check for symmetry. So first, we're going to check for polar axis symmetry. And according to this chart over here, we're going to replace theta with negative theta and then look at the resulting expression. So I took this equation and plugged in negative theta for theta. Next, we're going to look at this right here, sine of negative theta. Sine is an odd function, so this equals negative sine theta. So I wrote that right here. And now we're going to multiply 4 times negative sine theta. And a positive times a negative makes a negative, so you get r equals negative 4 sine theta. And then you can see that this expression is not exactly like the original, so then this may or may not have polar axis symmetry. So I just wrote the word maybe to indicate that. Next, to check whether this equation has symmetry about the line theta equals pi over 2, according to this chart, we plug in negative r and negative theta into this equation. So I plugged in negative r for r, and then negative theta for theta. So this is just negative r. And then the same thing's going to happen over here. Sine of negative theta is the same as negative sine theta. So next we're going to multiply these to get negative 4 sine theta. And finally, we'll isolate the r. So we're going to divide both sides by a negative. And when you divide both sides by a negative, you get r equals 4 sine theta. Since this is exactly like the original equation, this graph does have symmetry about the line theta equals pi over 2. So I just wrote yes to indicate that. Finally, we're going to check symmetry about the pole or the origin. And if we look over here, it says to replace r with negative r. So I put negative r in place of r, and then we'll rewrite this. So essentially, I dropped the parentheses and divided both sides by a negative, and you get r equals negative 4 sine theta. And again, since this is not exactly like the original equation, then the graph may or may not have symmetry about the pole. So I'm just going to write the word maybe. Okay, so to recap for checking for symmetry, for polar axis, you plug in negative theta. For theta equals pi over 2, you plug in negative r and negative theta. And for the pole, you just plug in negative r. You simplify each expression, and then you check the resulting equation. And when you check those equations, if the equation is different, then you may or may not have that symmetry. If the equation is the same, then you do have that symmetry. Moving on to part B, it says graph the equation using a theta R chart. So we have one set up for us. Let's go ahead and start plugging in. We'll use theta equals 0, then pi over 6, and then we'll keep going from there. So theta is equal to 0. We'll go ahead and plug that in right here. So we get 4 times sine of 0. Sine of 0 is 0. So we get r equals 0. And that means our coordinate point is going to be 0, 0. Next, we're going to use pi over 6. So now we have 4 times sine of pi over 6, and sine of pi over 6 is going to be 1/2. So we end up getting 2 for r. And then I'm going to write the point here. It's going to be 2, pi over 6. Okay, I'm going to pause for a second. I'm going to plot this point. So we're rotating 0, and then we go out 0 for r. Next, we rotate pi over 6, and then we go out 2 units. So here's pi over 6, and then we'll go out 2. Next angle we'll plug in is pi over 4, and then we'll do pi over 3, and then finally pi over 2. So sine of pi over 4 is root 2 over 2. And then here the 4 and the 2 cancel, so you get 2 root 2. So to plot this point, we're going to rotate to pi over 4, and then we're going out a length of 2 root 2, which I just put that in the calculator, and it's about 2.8. All right, so I went to pi over 4 and then went out almost 3, 2.8-ish. Okay, let's keep going. So we have 4 times sine of pi over 3. Sine of pi over 3 is root 3 over 2. And again, 4 divided by 2 is 2, so you get 2 root 3. So we're going to rotate pi over 3, which gets us right here. And then 2 root 3 is about 3.5. So we'll go out 3.5. All right, and let's go ahead and plug in pi over 2. And here we have sine of pi over 2 is 1, and then we multiply that by 4 to get 4. So when we rotate all the way up to pi over 2, we're going to go out 4. And next I'm going to connect these dots in that order. And this is kind of cool. We have half of the graph done, and we up here from our symmetry test figured out that this equation does have symmetry with respect to the line theta equals pi over 2, which is also the y-axis. So that means we can take these points and we can reflect them across to get the left half of the graph. And here's the final graph for r equals 4 sine theta. And if you look at it, it is a circle, and the center is at 0, 2. Radius of 2. So I have that labeled here. We have a circle with center 0, 2, and then radius of 2. Part C says verify the previous statement by converting the given polar equation to a rectangular equation. So right now the equation is in terms of r and theta, and then we're going to switch it to x's and y's. So first thing we're going to do is multiply both sides by r. So when we do that, we get r squared equals 4r sine theta. So next we're going to take r squared and replace it with x squared plus y squared. And then right here we have r sine theta, and we'll replace that with y. So technically we do have the equation with respect to x and y, but we're not finished. We're going to rewrite this. Let's first bring this 4y over to the left. So I subtracted that term over, and then next we're going to complete the square on the y's. So what we do is we take this b term and we divide by 2 and then square it. So we'll go -4 divided by 2 and then square it. So we get -2 squared, and 4 is the number we're going to add to both sides of the equation. And then the last step is we'll rewrite this as y minus 2 quantity squared, and then we add these together. And this is great because now we have an equation of a circle with center 0, 2, which is what we had before, and radius of 2. Now we're going to look at some polar graphs. The first type is going to be the circles. When you just have an equation where it's r equals a constant value, that's going to indicate a circle with center 0, 0, and then that value a is going to be the radius going around. Next we have r equals a cosine theta and r equals a sine theta. So if you have equations in either of these forms, cosine is going to be a circle that lies along the x-axis. A in this case is going to be the diameter, so then the center would be right there at half of a. And then for r equals a sine theta, it's going to be a circle that lies along the y-axis, and similarly, a is the diameter, where the center would be at a height of half of a. I have a note here, cosine again lies along the x-axis versus sine lies along the y-axis. For cosine, if a is positive, then the graph will lie on the right side of the x-axis. If a is negative, the circle will lie on the left. And then kind of similarly for sine, If A is positive, the circle will lie above along the y-axis, and then if A is negative, the circle will lie below. All right, so using all of that, let's go ahead and do the next example. It says sketch the graph of the given polar curve. Part A says r equals 2 sine theta. So since we have sine, this circle is going to lie along the y-axis, and again, this value A is going to be the diameter. So the circle starts here at 0, 0, and then the diameter is going to be up 2, and here's our circle. For part B, we have r equals negative 4 cosine theta. Because the equation has cosine, the graph will lie along the x-axis, and because A is negative, the graph will lie on the left. And again, just a reminder, the number 4 is going to indicate the diameter. So it's starting at 0, 0, it's going out 4, and then we'll draw a circle over here. And here's our graph. For part C, we have y equals negative 5 sine theta. Because we have sine, the graph will lie along the y-axis, and because A is negative, the graph will be below. And then I counted out 5, 1, 2, 3, 4, 5, and that's going to give us the diameter. Okay, so here's our graph. And then finally, we have part D, r equals 3 cosine theta. The graph is cosine, it lies along the x, 3 is the diameter, and 3 is positive, so it's on the right. So here's our polar curve. Next, we're going to graph limacon curves. The equations are in the form of r equals a plus b cosine theta, r equals a plus b sine theta, or there could be a negative in between. If the equation has cosine in it, then the graph will be symmetric about the x-axis. If the equation has sine in it, the graph will be symmetric about the y-axis. There's 4 types of limacons. You can have an inner loop, cardioid, dimple, or convex. I like to repeat that over and over so I kind of get it memorized. Inner loop, cardioid, dimple, convex. Let's say it one more time. Inner loop, cardioid, dimple, convex. And then what you do is you identify the A and the B values from the equation. Notice up here A and B are defined to be positive, so you can disregard any negatives. When you find A and B, you put them into a ratio and you check the ratio. If the ratio is less than 1, then it's going to be an inner loop. If the ratio A over B is equal to 1, it will be a cardioid. If A over B is between 1 and 2, it will be a dimple. And if A over B is greater or equal to 2, it will be convex. So one more time, you do have to have this memorized. So the way I memorize, it's not that great, but I just keep repeating inner loop, cardioid, dimple, convex. And then I take the ratio and say less than 1 equals 1, between 1 and 2, greater or equal to 2. And so if I memorize them in that order, I can kind of line them up to figure out what type the limacon is. Here we have a few notes regarding how to draw the graphs. If the equation has cosine, then the graph will lie along the x-axis. And if it has sine, it will lie along the y-axis. The plus and minus stays consistent in these graphs to the circle graph, so that's really nice. And then we have the value of A will be the width. Then we take A minus B, and that will be the top point. A plus B will make the bottom point, and then we'll go ahead and go through how to graph it out. This example says sketch the graph of the given polar curve. Part A, we have r equals 2 plus sine theta. So A is 2. And B is the value in front of sine, so it's going to be 1. The ratio A over B is going to be 2 over 1, which equals 2. And then if we take this ratio, which is 2, we check it up here, and it's going to be greater or equal to 2. That means this graph will be convex. I have a little spot here for a mini graph just to get our point of reference. Because this equation has sine and a positive, the graph is going to lie along the y-axis, and then the plus means it will be up here. All right, so the point of reference, we'll start at the origin. A is how far we're going to go out on both sides. A plus B is going to be how far we go up. And then A minus B is going to be this point here. Let's go ahead and graph that out. So A is 2, that's how far we're going to go out to the right and left. So we have these 2 points here, and then I just labeled that, that's the A. Next, we're going to go A plus B, and it's going to go this direction. So A plus B is going to be 2 plus 1, and you get 3, so that's how far we're going to draw the graph this way. So there's our top point. Next, we're going to do A minus B. So A minus B is going to be 2 minus 1, and you get 1, so that's how far out we go this way. And then we'll just connect these dots to make it look like a convex shape. And there we go. Moving on to part B, we have r equals 2 plus 2 cosine theta. So A is 2 and B is 2. Next, we'll look at the ratio. So we're going to go 2 divided by 2, and you get 1. So when A over B equals 1, that means we have a cardioid. And then let's go ahead and draw a mini graph. Since we have cosine, the graph is going to lie along the x-axis, and since we have a positive, the graph is going to be over here. So kind of picture you had this one, because sine was positive, it was up. For cosine positive, that means it's rotated on its side, coming out. So there's our mini graph, and let's go ahead and graph it here. So A is how far we go out in this direction, up and down. Next, we're going to do A plus B, and that will be how far we come out this way. So we get 4, so we're going to come out 4. And then next, we're going to do A minus B. So 2 minus 2 is 0. So this number tells us what we're doing over here. So 0, we don't come out at all, and then we are going to draw our cardioid like this. All right, and there's our final graph. Oh, and then for notes purposes, can you go back and label this on the first graph? So again, from the center out is length of A, and then A plus B is how far from the center you're going back, and then A minus B is how far you're coming in this direction. So maybe labeling this will help when you're looking back at your notes. This example says R equals 1 minus 2 sine theta. So A is 1 and B is 2. And don't forget, A and B are always positive, so if there's a negative here, just disregard it and then take the A and the B. Next, we're going to write the ratio, and you get 1/2. Then when we look up here, we check our ratio, and since 1/2 is less than 1, this graph is going to be an inner loop. Okay, next we're going to do a mini graph. Since the equation has sign and negative, that means the graph will lie along the y-axis, but it's going to be down here. And there's the graph. So again, it's down here, but the inner loop is on the top. So on here, we're going to go out A. So we're going out 1 in both directions. Next, we're going to do A plus B, and that will tell us where to go down here. So A plus B is going to be 1 plus 2, and you get 3, so we're going to come out 3. Next, we're going to do A minus B, so it's 1 minus 2, and you get -1. So since this value is negative, that means we're going to come into the graph. So I came in 1 unit, and then now we draw the inner loop. So here's our graph with the inner loop, and that's it. All right, guys, thanks for watching. This was Math with Yosh, and have a great day.